Hi students, this is Mr. Yao. Today we are going to talk about 5.5b, where we will learn more about how to use trig functions to solve story problems. Today's lesson is mainly focusing on something called compass bearing. Compass bearing is the direction towards which you are headed, as shown by a compass. It is most commonly written in the form of n 6 degree e. That actually means north 6 degree east. The meaning is the bearing that makes an angle of 6 degrees with north towards east. So let's quickly draw some directions. Up north, down south, left is west, and right is east. So this angle, north 6 degree east, is going to be first starting with north, and then from north it's going to turn 6 degrees towards east. East is on the right side, so basically turning 6 degrees towards east. I did draw the angle a little bit bigger so that you can see. This is 6 degrees, and this right here, the arrow would mean north 6 degrees towards east. We typically draw north and south first. We typically actually write them first before we write the east and the west. The angle will never exceed 90 degrees. For example, even if you have something, say, like down here, this angle, yes, it does look like it's more than 90 degrees, but if it's down here, we may actually start with south first, then it's just turning this little portion instead of going more than 90 degrees. That's why it says the angle will never exceed 90 degrees. Now let's have a look at some practice. Example 1. Write the correct compass bearing for the following points. For point A, it's up left, as you can see, up and right. So that's why we start with north, and then the angle is 30 degrees. To the right is actually east, so it's north 30 degrees towards east. For B, is up, but this time is left. That's going to be north. The angle is 60 degrees. Since it's to the left, it's going to be north 60 degrees west. And next, for C. This time is going down and right, so it's not going to be north anymore, it's got to be south. The angle is 70 degrees east. And D is going to be south, it's going down, but the angle is 80 degrees, and it's pointing to down left, it's got to be the west. And that is how we write the compass bearing. Next, let's have a look at some more tangible application examples. Example 2. A sailboat leaves the dock at a bearing of north 37 degrees east. So for all of these examples, it is very important to be able to draw the description correctly. That's going to help a ton with setting up the equation and solving for what we need. So let's have a look. First, since we need a compass bearing, let's start with the general directions. We have north, we have south, down south. We have west on the left, and we have east on the right. So north 37 degrees east. North is up, 37 degrees east. East is on the right, so it's got to be somewhere around like here. And this is the 37 degrees. It traveled for a distance of 100 kilometers. So this is 100 kilometers. That says right here, right now. Immediately after, the boat turns and travels due south. Here's a word that we don't hear often, due south. That actually means directly toward south. That's what it means. So after the 100 kilometers, it's going to go down. It's going to due south. How far does the boat need to travel in order to be due east? Due east is basically pointing directly to the right of the dock. This is the dock. Directly due east is somewhere along this side of the line. And we need the boat to be on that line. So basically that means when the boat travels due south, it's going to keep travel until it hits a point on this line that is due east to the dock. So there we go. You can kind of see, because south and east clearly form a 90 degree, we do have a 90 degree angle right here. So we do have our right triangle. And is asking how far does the boat need to travel. So this is the part that is actually asking. I'm just going to label it as X. Now we do have a right triangle right here, and we are trying to find out about that X. Then of course we need some angles inside the triangle to help us set up the equations. If this angle is 37 degrees, this is a 90 degree, this would have to be 53 degrees. And with that angle being 53 degrees, we can clearly label the opposite adjacent hypotenuse, 53 degrees facing our x. So this is the opposite. This little portion is adjacent, and then of course the 100 kilometer is the hypotenuse. So we can use sine, since we're trying to use opposite and hypotenuse, we can use sine. Sine 53 degrees, that is going to be opposite, which is our x, and our hypotenuse, which is 100. And then of course I'm going to multiply both sides by the 100. So x equals 100 times 7 sine 53 degrees. Put in your calculator, that should give you 79.8, actually 0.9. The question is saying round to the nearest tenth. 79.9, don't forget a unit, kilometer. That is example 2. So you see, as soon as you finish drawing the whole thing, you will see a right triangle clearly, and that's the one we are working with. That's example 2. Next, example 3. The planes leave from the airport at the same time. So let's try a compass setup. North, south, west, east. Plane A travels at a bearing of south 45 degree west. South is here, west is here, so 45 degree southwest is going to be around here, and this is 45 degrees. Next, plane B travels at a bearing of north 45 degree west. You may have noticed I've skipped some stuff. So I didn't actually read this part. Well, because that's a number that's not about the bearing. I'm going to set up all the bearings first. So a bearing north up and west is on the left, so 45 degree. That's what it would be. And this right here is the 45 degree angle. And as you can see, this is a straight line. If we know this part being 45, this part being 45, then we can clearly know it's a 90 degree angle right in the middle between the two lines I draw. Next, the question is asking, after 2 hours, how far apart are the planes? So you see, now is where we're going to use the speed, because the planes are traveling at a certain speed for 2 hours. For plane A, which is down here, plane A travels at 527 miles per hour. For 2 hours, that is going to be 1,054 miles. As for plane B, travel for 2 hours of this direction. That is, each hour is 650. So 650 times 2, which is 1,300. And it's asking, after 2 hours, how far apart are the planes? This is where plane B is. This is where plane A is. So clearly, that is going to give us a right triangle with this angle right here being a right angle. So that means all we need to do in this case after we finish the drawing is to just simply use Pythagorean theorem. So the distance that we need is going to be square root of 1300 square plus 1054 square. We're still gonna follow the same requirement to round to 2 decimal places. And after I type in the whole thing to the calculator, that gave us 1300 squared plus 1054 squared, parentheses, that is going to be 1673.6. Don't forget a unit, kilometer miles. That is example 3. Next, example 4. A DC-9 aircraft leaves Midway Airport from a runway whose bearing is north 40 degree east. Well, let's find out. This would be the airport, north 40 degree east. It's kind of close to halfway, which is 45. So it's kind of almost in the middle, but that's about how it is. North, south, west, east. And next, well, let me actually make the drawing a bit smaller. Like this. Okay, and that is 1/2. So, well, north 40 degree east. So this got to be 40 degree, and this is 1/2 miles because it says after flying for 1/2 mile. The pilot requests permission to turn 90 degree and head toward the southeast. So we have a little direction, that's north, that's south, that's east. This is the general direction of southeast. So basically it's saying after I got right here, I hit a point, I'm going to turn 90 degrees, which would give me this part. That is a 90-degree angle and it's heading clearly to southeast. And this time, after the airplane goes 1 mile in that direction, what bearing should the control tower use to locate? So here's something important. This is saying should a control tower to use to locate the aircraft. It's not the aircraft that's trying to find out the control tower. So here's the actual relationship we're going to represent. It's a line towards the outside because that is how we start with a control tower. As for the bearing, well, of course, we're going to find some angles. But if you just look at this triangle right here, that is a right triangle, which makes a lot of things easier for us to find. Because we know one side is a 1/2, the other side is a 1, and we also know there is an angle we can use to present right here. So if this is the angle we are trying to find, then this would be the opposite. This would be the adjacent. So tangent, and let's actually call it theta. Tangent theta equals the 1 over 1/2, which is 2. And we have learned already, if you're trying to find the angle, you are going to need to use inverse function. So it's got to be the inverse of tangent, so tan -1 of 2. If you type that into a calculator, that is going to give you 63.43 degrees. But that is not fully done. If we want to figure out the actual bearing, we're going to need to do a bit more. The actual bearing, since, well, you can kind of clearly see this line is pointing down in that 4th quadrant. So we may want to just use whatever S is to actually find out the bearing. Since it's pointing down, we're going to use south, that's for sure. Then you will realize we're going to need to find out that angle. And then eventually we're going to put east. So now let's see how we can find that angle. If you remember, the straight line, the angle for a straight line is 180 degrees. And the front the front part is going to give you 63.43 as this part. And that straight line is 180, so in order to figure out our question mark, it is going to be 180 degree minus the 40 degree, then minus the 63.43 degrees. After calculation, that should give you 76.57. And that is the angle we actually need, and this is the bearing we actually need to present from the control tower to the aircraft. That is example 9. Last one, example 10. A battleship is 100 miles east, well, let's draw it out, and 110 miles south of its home port. This is got to be the home port, north, south, west, and east. This time, it takes 100 east. This has got to be 100 miles. Next, 100 miles south. Well, then we're going to go down to south. That is 110. And it's asking what bearing should it take in order to get home quickly. This is where we need to clarify. It's asking the boat needs to take in order to get home. It's not from the control tower anymore. Basically, the boat is right here, and it's trying to find out what direction is that in bearing. So first, no matter what, based on the 110 and the 11, we can solve some of the stuff in this triangle. We can clearly find out what that angle is. That's opposite, that's adjacent, so it's going to be tangent theta again. It's 110 over 100. And in this case, again, we are trying to solve for the inverse. So we are going to do we're going to type in our calculator and see what we're going to get. That should give me 47.73 degrees. Now the question is asking what exactly is the angle that we need right here, because that is how we're going to represent the actual bearing for the direction. That's one way to do it, or I can change my theta to be that question mark. So tangent question mark is actually going to be 100 over 110. And in this case, I can actually use my inverse function. I actually forgot to write that. The inverse function for this theta is inverse tangent of 110 over 100. Now I'm going to find the inverse. So the inverse is tangent -1 of, let's say, question mark equals 100. Well, not there, actually. Is going to be 100 over 110. And see what angle that's going to get me. Tangent inverse 100 over 110. That is going to be 42.27 degrees. So clearly they do add up to 90 degrees actually. So after we find this angle, remember this is the bearing that the boat is taking towards the home port. If someone else is asking, hey, but what if the actual bearing from the home port to the boat? Well, that is going to be the exact opposite of what we're going to get. Since we have 42.27, up is north, so it's got to be north, 42.27 degrees, and on the left side is right here, which is, sorry, let me rewrite that, north 42.27 degrees, and then we are going to have towards the left, so west. That is the whole bearing if of the boat taking to get home. But if I change it, I say this question as, what is the bearing that the home port, that home port is trying to track of the battleship? Then in that case, it's going to be this direction, and that is going to be south, 42.27 degrees east. So it's completely opposite. It's north facing south, changing into south, and west changing into east. Now that is example 5, and that is everything for not 9.5, for 5.5b. Thank you.